Welcome everyone to large language models, introduction to large language models, specifically retrieval augmented generation. And then the most of this workshop is going to be focusing on building a retrieval augmented generation system. And that's the second part we'll be getting to, and that's going to be the coding part we'll be doing. And you'll see that in just a bit. Well, to put it simply, large language models are pretty much right. And this basically helps in predicting what is the next word in the sentence based on all the previous words in the sentence. And it remembers what it's seen so far to predict the next word. For large language models, however, they use something called transformers, and I will quickly do a quick overview of that in the next slide. Again, these are just different ways you can, make language models really. They acquire emergent abilities. In other words, emergent abilities really just means abilities that weren't there before, but now that it's really big, it somehow showed up. The large language model can learn from these additional information you gave it to it, right? And so that's in-context learning from the context. Again, this is really, really, really high level, but I think really cool. Really cool at it, really cool stuff. And if you're interested in reading more about it, I recommend looking at the post illustrated transformer. There's a paper called "Attention is All You Need," which retrieval augmented generation can solve, and you'll see just a bit. See the time. And then using the external data source, it will append this context back into the entire prompt. We'll see this in action when we do the quick coding project. It will append the entire coding, it will append the entire, what you call it. And then the prompt will have the context retrieved plus your question so that the model can answer the question using the context it has retrieved, right? So this is the whole chain. You have a question, you retrieve some relevant information, append the information into your question, and get the answer that hopefully is much more accurate. And then use embeddings to retrieve the relevant information from the vector store. RAG should help this problem by retrieving the relevant context to answer that question. You can spend a whole lecture on, like a couple lectures on actually. But the main point I want to take out here is embeddings are basically ways to represent words, or in our cases, sentences, documents, as vectors, so that we can find similarity between them. Right? Like right here, right? You obviously can see that the word man is much more closer to the word woman than to, at least based on the embeddings they have made so far here, and they are closer together. Okay, someone has a question. For embeddings, are third-party APIs like OpenAI or AWS a lot better than open source local host ones? But it's just they have much more data, and they can probably do a better job, seeing that they have much more resources at it. Is any IP privacy issue with integrating local data with OpenAI API? A couple ways I can answer this actually. One, if you send a message to OpenAI's large language models, right? Send a user API. It's basically like sending stuff in ChatGPT, and there will be the same privacy losses, whatever you're using the ChatGPT, I'm pretty sure. Another way is you can fine tune a model, and that is using the models they have. You add some more data on top of it so that it can, let's see, open it up in another account. And then, right, you shouldn't have, this changes will not be saved. So if you want to use it, I think you can connect to it and then just press connect. These are libraries, these are packages. And so you can install these packages whenever you want.
Wait.
You do need to pay for it. To use the packages, to call on the OpenAI APIs, like to call on their program to do completions, you do need to pay for it. For the purpose of this project, I'm sharing my API key with everyone. So first of all, don't share with anyone else. And then I'm going to be disabling this API key in like 30 minutes after the class ends. So for this project, you're going to be spending my money. So then let's say the model won't be able to answer your question. What do? You need to give the model relevant information to answer that question. It's like answering a question. It's like answering your classroom question. Like if you have a reading assignment and then you want the model to answer your reading assignment questions for you, you could just ask a question. You could just ask GPT, hey, who is Luke Skywalker's father? Or you can find relevant quotes from the movie, put it into the context, and then ask the question. You could build a RAG system vanilla, like do it all by yourself, right? And again, this is my key. So again, don't share this with everyone. I am very serious about this. I am a broke college student and I need the money. So first, let's build RAG. And run the model, run the thing. You need these packages.
I have a question.
To work. Yes. And then for each Wikipedia page, it's going to collect 4,000 articles. As you can see here, it's now downloaded 50 documents once you run it, right? And if you run this, these are the documents it has collected. So the first document is called Star Wars. Let's say if you embed the word apple or you embed the word banana, right? Like the embedding is obviously going to represent the word banana or apple. if you embed this entire paragraph, like what the hell is a model? Sorry, what is a model supposed to represent? You know, so what we need to do is we need to make this in big, huge document chunked up. We need to chunk them into smaller documents, smaller. I call them chunks. Some libraries call them nodes or just smaller documents, whatever you call them. Or you can split them by character length, like after every 200 characters, no matter what, you split them. And feel free to modify these parameters. Like I can make this 512. Let's do 2048. They are the closest, like literally distance-wise, closest to the embedding you're querying from. So first, using LangChain, you first need to create the embedding object. We're going to be using the cheap model because second, you need to transform that query into a vector embedding. Same step as what you've done up here. So let's say we have a query called "Who is Luke Skywalker's father?" Right, and this is the top 3 documents you've retrieved that supposedly will answer your question. What it really means is these chunks. Can I take a look at that later once we start working on the individual work part? I'll take a look at your code in just a bit. Is that all right? Like what we just talked about, but a lot of things RAG cannot do, and is that RAG really depends on the quality of the retrieved context. Sorry, there's a typo here. This is everything we've done. You could do the same thing, and then you could, instead of loading in Star Wars documents, maybe you can load in a document on, I don't know, and then you can build your own storages. I recommend specifically for RAG to solve really niche problems. Because usually if you have a general question like who's the president, the large language model probably already knows how to answer that question. And then what's the point of making RAG? Something more niche, something that's your passion, maybe like a book you're reading or a movie you know about, or like a fandom page, or let's say the Pokemon index page. Something more niche that the model may not know about, but will benefit from this information, from filling in the information gap. I say that's where RAG really shines out most. So if you're just joining in, feel free to open up the notebook and take a look at it. I don't know your name. Sorry, you have your initials on it. Do you want to just share your screen now, or would you rather? I just use pip install. Pip install makes everything easier. I think it's also just pip install. Let's see, room 1, 2. Okay, I've made 2 rooms. If any one of you have questions that you don't want to ask questions in open, also just join a room as well, and then I will be there. All right, I see more people joining in now. I'm assuming there's another workshop coming up. Is there? I'm not sure.
I was reading the web base loader thing and I'm completely confused.
You can do that here. If you look, just search up OpenAI register for API key. And I should stop. I can't stop recording. All right. Thank you. I don't know why I'm filled with the Pokemon stuff, but let's say you want to scrape the Pokemon Wikipedia page. Let's see what is Pokemon Wiki right here. Right. You have this document right here. A web page is filled with HTML information. And this is a web page itself. So what this web-based loader is hopefully going to do is you feed it some link and you'll be able to.
Wait, but after I have that, don't I want to be able to like pull information from that?
And that contains the list of the documents from these links. That makes sense so far? Okay, I was going to say it's up to you to remove them, but that's probably wrong. Let's take a look. I think LangChain has a way to do its PDFs just because,